All right. Hey everyone, what's going on? It's pretty early here. Hoping people will be enjoying this stream. I've done a couple of those yesterday. It was so much fun, and I think I would like to do quite a lot of those kind of streams in the future. So yeah, hopefully audio is okay. I didn't change anything since yesterday, so hopefully I didn't screw up my settings completely. Hopefully audio is good. I can maybe try bringing up the gain a little bit higher. Hello. Okay. So yeah, so here's what I'll be doing, and I'm going to recap a little bit of what I have been doing in these last streams. What happened is the history of this is that I was talking to a few people in the community, mainly Josh, the audio programmer, and Julian Storer, the creator of Juice. And we've talked about all these different interesting things that would be great if they were available. And one thing that Jules mentioned is that currently, if you're doing something like, if you just want to load audio drivers in your app, like SEO, Core Audio, all that stuff, it's not very simple to do. Like if you're using something like Juice, then it works really well. But if you don't want to bring in such a heavyweight framework, then it's a bit more difficult. There are libraries that do that, and I will be wrapping one of those today. But the libraries that exist have a lot of verbiage until you actually get things right, and there's a lot of mechanics that aren't solved in those libraries, like loading the configuration from a JSON file or JSON object. Stuff like doing, kind of communicating from the UI with that library. So a lot of those are not solved, and then you kind of have to write these big manual solutions on top of the library. And that's pretty much what I'm doing. So I'm writing this cross-platform library. It's going to be free and open source, and it just does this. It just handles kind of wrapping the drivers for. At first, it's going to be Mac, Linux, and Windows, and then when it's more elaborate, more complete, I'll probably write more backend so that it could support iOS, Android, or something. But the idea is to give a very clean-looking interface, something that's very, very simple to bring up from a C++ app. Like you can just start a console app, you bring a header or something, and with a couple of lines, you can get audio, and you can do all these connecting to the device and changing it. So it needs to be something that a programmer who just writes, a DSP library, or they just write some audio software that's not, a full-form DAW, maybe even a full-form DAW. Like they could just bring this in, and the audio in general is taken care of in terms of the flow into the driver, out of the drivers, and all that. So. Yeah. So what is happening is that there's actually a repository that I opened that's public. I will be linking to it. Notice that even though there is code there and it compiles, it's very, very much initial. Like there's a lot to do until this is ready. So please don't make any apps using this until this is more complete. Like don't tell me that you've built a product with my library, because there's no guarantees about this right now. Like there's definitely a lot of things there that are kind of like placeholders that I will be perfecting and fixing during the stream. So yeah, so this is what happens. So first of all, I'm going to link here so that people could see the link to the repository. You can follow. I'm going to be committing during the stream. You can pull it. If you're a C++ developer, you know that if you're using something like an IDE or something that's using CMake, this is just going to work. So, for example, when I'm going to my IDE, which is CLion just opens. Let me remove this. So CLion just opens CMake, natively. So I can just go to open. Code make a sound. That's currently the name of this library, and I just opened the library. CLion, other than this is a beta, so it shows an error. Ignore that. CLion will automatically knows how to configure this, like even if I didn't have this configured. So this is like almost like just opening this from nothing. CMake will, let's see the CMake window. CMake will know to, it's going to fetch RT audio, which is the underlying library. If I'm going to add more libraries, they will just be auto-fetched. And you can just build, like you see, there's an example app and you can build it, right? You can click run. If you're using like another IDE, like something like Visual Studio Code will support this also natively, Visual Studio as well. And if you're using something like Xcode or something else, you can also use that by going to the command line. And then you can do something like generate an Xcode product, doing something like CMake -G, Xcode -B build or something. And, capital X -B build. And this would generate an Xcode project that would just compile and run. So this is, it's pretty flexible. We will probably be talking more about what the build system is going to be like. Maybe this is going to be eventually header only. But the project itself is running CMake, and it's I didn't test. I'm only compiling here on Mac, but it should work just fine on Windows and Linux. Okay, so let's see. Maybe someone can, by the way, I'm going to be looking at the comments, so if you have questions, you can let me know. If you're hearing me, seeing me, let me know if everything is technically correct. I will be trying to make this instructional, so I will be, talking a lot about C++, I guess, techniques or just build system techniques, and I will probably be diverging from whatever it is that I'm doing into like be more explanatory and kind of give more of a context. So as said, we're making an audio drivers library in C++. It's basically a wrapper around it. Currently, it's a wrapper around an existing library called RT Audio, but I will be eventually using different backends. So this is where we are. So let's explain where we are right now. Where I am, I want to first look at the user code of this, like my example app that I've done to emulate how a user would interact with this app. So the idea is a user. Look at this main thing. The idea is that a user, here I've done two different configurations just to test that it works, probably not needed. So the user can actually not do all this stuff, right? The user does not need this function. This is like my testing function. The user can just do manager get default config or something, right? What was I missing? Oh. Yeah, I think it's make sound like a static function. What is it? It's too early in the morning for something like this. What's going on here? This should be static. Oh, it's not static. It is a stateful function. How did that work before? I'm blacking out. Oh yeah, here you go. Extra parentheses. It's too early in the morning for fixing syntax error. Anyway, so the idea is, let's say I do something like this. Well, true. So let's say basically these two lines, right, is everything you need to get audio. What this will do by default is that this is going to bring up the device manager is going to look for the default device. That's what the default config, what the default audio device. There could be a lot of audio devices on your system, which you've probably seen if you've selected your audio configuration somewhere. Like for example, if you have an external audio device, you'll have the external one show up, but also the internal computer one show up. So you use the default config, and then you attach a process block function, right? And this is basically the process block function. Goes through all the channels and all the samples and makes a sound. In this case, it's white noise. So this is where I am. This is user code, right? The idea is that user code, there's a few things here I've done for the examples. I probably shouldn't have committed those, but doesn't matter. This is like allocate memory, etc. Good. So here you go. My first commit here would be, let's do something like, first of all, let's see that it works. Let me build this, run this. Awesome. I do hear, hopefully you hear it as well. So I do hear sound coming from the audio interface. So first of all, first commit is fix example project or something. Good. Okay, so here there's just to let everyone know, I am streaming here on a few different platforms. So this is goes on Twitch, YouTube, Facebook, and LinkedIn, Twitter, or X, I think. So whatever comments you write, I'll make sure that everyone sees them. So feel free to ask questions, and I will kind of pass those along to people watching on the other platforms as well. Okay, so let's talk about what I wanted to do today. There's a few things I wanted to do, both to the way user code looks, which I still think could be improved, and the way, but also I think that there's a lot I have to do with the implementation, because the implementation here currently, in my opinion, is pretty messy. Like I need to, there's still a lot of, let's call it leaky implementation here, where the header, this header still includes, the RT audio backend. There's still functions here that are talking directly to RT audio, and I wanted to take a few steps to remove that. Okay, please remember, let me know in the comments if everything works, if my audio is heard, if I'm not talking to myself here. I'm hoping that everything is patched as it should. Look at my settings. Hopefully this is okay. Okay, so the first thing I'm going to do is, probably will be a good start, is to start separating this whole thing into something that could be an interface, kind of like a clean interface that does not have any of the RT audio, let's call it implementation details in it. So I did do some of that work during the streams yesterday. So what I did do is I created this header file currently called device info, which just has a bunch of structs, basically. And all these structs are just plain C++ types, like bool, int, and sometimes std vector or std string. And some of them will be just my types, like flags is another struct. There might be a std optional here, stuff like that. But it's all really basic types, except for this type that has a few helper functions. But they're all pretty basic, basic types that are created so that all the implementation details of the RT audio backend will be hidden behind it. However, there's still this class, this file here, make a sound. This file is still very, very much connected to RT audio. So all this stuff probably should be moved into RT audio, and I probably should create another layer that hides this. Okay, so let's start with that. What I'm going to do, I mean, most of this stuff, most of this implementation should probably be moved as it is. And then I'll create some other interface that kind of forwards these calls to this. Yeah, like one simple way to do this is hide some of this stuff behind the CPP file. So far, I was keeping this header only, so I'm trying to think if putting this behind, you know, how do I technically do this? There's a number of ways where I can do this. So let me think. One way is that I will create some interface header file and then an implementation header file. That's one way to look at this, which is I think quite common in libraries like this. I was just trying to play some music on my Spotify from my headphones only, and just quite loud. Okay, this is less loud, probably better. Okay, so I am going to start with so this, I have this file called RT Audio Backend. This is probably all this stuff. This is all these like conversions from the my types to RT Audio types. What I probably could do with this is let's add another file here. Let's call this RT Audio Device Manager or something like that. And I'm just literally going to copy this whole thing in there. Right? It probably should be exactly as this. I probably need to. This is not needed, and I probably just need to wrap this whole thing in like a namespace or something. So I'm going to start here. This is going to include the backend in that folder, and I will also add some little namespaces. Like I'll call it something like RT Audio. And here I will do the same thing. And then here, yeah, so I'm going to call another file, which is going to be for now in the interface, but I'm going to call it device manager. Let's call one of them device manager. And this file is probably device manager. Let's call something device manager implementation. Implementation. Yeah, so there's going to be two things. There's going to be device manager, interface, and an implementation file. And for now, the implementation will just default to use RT Audio, but I will make this kind of composable, I guess, in a second. So here's how I'll do this. So I'm going to go here. So I'll make a sound, and I don't need this function because this is an implementation function, and I probably need yeah, so I just need probably just the function names in this, right? Yeah, I think I just need something like this. I just need to kind of make this happen here. No. Oh my goodness. Yeah, I can just do kind of just declare the functions here. Yeah, I think this is what I'm going to do. I'm just going to declare the functions here. Maybe I'll do something else. Maybe I'll do it some other way. Let's see. Let's bring the implementations back. Maybe I will add. One way I can do is which probably will make it simpler for me to work on. I can probably add CPP files here, and then later I can load these CPP files as headers. Yeah, maybe I'll do that just as a way to work on this before I convert this into header only. Yeah, let's do that. So what I'm going to do, I'm not going to do this implementation file. I will do this later. This will make more sense in a later stage. I will do something like create device manager CPP. And then yes, great. So now I'm going to copy this whole thing into the device manager. And what it is going to bring is this thing will just need to bring yeah, I don't need everything here. It's just going to be literally nothing for now. It's just going to include device manager because it's probably going to be like a midi device manager coming pretty soon here. And then this would be, let's see. Good. So I need to add, first of all, I need to add this to the build system. So this would have, this would mean that the library itself would have something like a target sources, make sound, interface, make sound, / device manager .cpp, something like that. This should add this file. Oh, because it's under include. Do I really want to do this under include? No, I don't know. You know what? I'm gonna wait with the CPP file stuff. I'm gonna see if I can get around it and somehow create this thing. And I will try to handle the challenge of doing everything without CPP files, just so that I can be more conformant to the style. So I'm just going to go here and refactor this file name. Refactor, rename. Let's do something like, let's skip this implementation.h. Let's do this. And then I'll remove this from the build system. I will just use a way where you're kind of including the implementation later in your code. I think that will make more sense. Yeah, let's start with that. That'll be I guess a rudimentary way to do this, where I wonder if let's see if CLAN is going to know to move these implementations automatically if I don't do it manually. That's going to be an interesting one. Why is CLAN not finding my the reference from this to this? It should, right? I'm including the implementation file. That includes the header file. The header is right here. Okay, so now I'm just going to move this into the separate CPP file. So I didn't know to do that in the implementation because probably the namespace wasn't there. Maybe I'll give it a namespace because I wanted to just move all of this definition automatically. Let's see if it will know what I don't want to do. If I do this, is it going to know? No, I didn't know. Let's. What if I add one of the implementation myself? Like, let's say I take this here and I move this over here. So device manager. Oh, it still looks for the CPP file. Constructor should have an inline. Okay, so this should be an inline. That makes sense. That's fine. Does it know how to do that with this file? Yes. Good. Now I can just move all of them with one go. So I can just pick everything here. All these private implementation files probably don't need. I just need the public stuff. So all of these. And all the private stuff will probably be moved somewhere else anyway. Yeah. Please let me know in the comments if you want to know something, if what I'm doing makes sense, if it doesn't make sense. I'm here writing a driver library in C++. Okay, there's a bunch of errors, but that makes sense. Really, what I need to do, it added some crap here. I did not do this move correctly. Interesting. It screwed it up. Why did it screw it up? Sea Lion, why are you acting up on me? So this one by one, is it going to work fine? Yes, it's good. So the idea is that everything that's public here in the device manager, all this stuff will slowly but surely be completely detached from this library. It will be like just work with my types with the, and we'll have some hopefully clean public interface. Yeah, let's try moving a few more of those together. Let's see if CLion is not going to screw those up. Yeah. That's it. It stopped letting me just move these automatically. I'll just move those myself, I guess. Yeah, that's it. I hate when I have to do this stuff manually. It's because I'm trying to do it header only, and I guess CLion doesn't like that. Right, maybe it's going to figure it out now. So you remove all these private stuff. And this audio callback, because this depends on RT audio. Yeah, so I'm here just refactoring things and moving these implementations into this implementation file so I can separate the library. Remember, I'm here streaming on a few different platforms. So if you're reading this, if you're watching this and you have questions, let me know in the comments. I will be posting your comments on screen so I can share it with people from the other platforms. Okay, so I went back to doing this stuff for me automatically. That's nice. Good. So the idea is that now, before I clean up the implementation, there's going to be a very, very clean looking interface. Still not as clean as I'd like, but it's this is better. This probably should be in the private, by the way. I'm not going to allow access to any of these objects directly. And this will just be, something like the public interface exposed to users of this function. Now I need to clean up this implementation, because what this implementation is to do is actually create the RT audio device manager and kind of forward these internal calls. And to do that, I will use something called a pimple. And a pimple means that I will just be making something like I'll use something like a base class here. I will write some base class over here. Called something like, it's going to be something like let's do something like I guess I can use something like stud_any here, or I can just use this. I can just use something like use an internal device manager. There are actually nicer techniques to do what I'm about to do. I will do something pretty raw. So this will do something like internal, or let's call it device manager interface or something, with a virtual destructor. And this is something that's not going to be exposed to users. This is something that will just be a way to kind of connect internally from this from the implementation, so that it's not let's call it discussed directly with this. So what this can do, I can use this and implement a bunch of functions on this, or yeah, could do it like this, or what other way I can do this in, I think. Because what I really want is so that the device manager implementation, see all these red dots here, all this stuff should probably be forwarded into RT audio functions in the case of RT audio. You know what? Let's wait with this. Let's wait with this abstraction, even though it's probably a good thing to do. I will wait until I get this more complete. So I will start with the implementation currently, including RT audio directly, but that would mean, I probably still need to have some pimple in here. How am I going to do this? Let's see. What would be a good way to do this? One way is I can do some, because what I want is I want to have access here to all these functions, and I can just go and include RT audio device manager. And when I will have, for example, when I will have an RT audio device manager, whatever it's called, in here, then I should be able to just call this, right? Call set error callback or something, right? It's something like RT audio device manager or manager. So when I have the manager, I probably need to expose this function, probably private or something. Right, where's this thing? How's everybody in the comment section doing? Let me know. How are you on this pleasant morning or afternoon or whatever it is you are? What would be the best way to do this? Um, yeah, so what I'm going to do for now is I can probably do this without even a base class. Just assume that there's a single base class. So I can do something like, let's see, I can just say something like, but how am I going to call this without a base class so that I can have some forward declaration of that? I guess I can use stud any. No, let's start with stud any. I'm just going to do that. It'll be, I think, a simple way to do this. Stud any is something in modern C++ that should, at least in theory, work in this manner. I think I should be able to do something like stud any implementation or something, or let's call it device manager. We're gonna just call it pimple, I guess, pimple. And what I could do is in the constructor right here, where I am aware of a specific implementation, I can do pimple equals this, something like that. I think this should work. And what this means is that I need also a way to reflect on the, so that I can always kind of reach back and grab the data on this. So the way to do this is I can do something like, I'll have a helper function that says something like get concrete, and it's going to take stud any, and it's going to return something like any cast, stud any cast off RT audio device manager. Do I need to yeah, I think this is going to work, right? In line. I think this is going to work. Let me just make sure that I remember this exact syntax. So I always like to, when I try C++ features, I like to start just a new console project. I do that often, just to make sure that I have some control over the syntax and the semantics of what happens. So what I'm going to do is I'm going to do something like struct, my struct, right? And I'll give it a couple of functions, like let's do something like x equals 0, and then I'll do something like set x. I'm intentionally using functions here just so that I'll see that they're actually getting called. So I'll do something like set x and x to use, and then print stud cout x. And what I want to check is that I actually understand the semantics of stud any. So I wanted that so that I can do something like stud any any or anything. So and then anything equals my struct. That's how I stored the thing in it. And then I should be able to do something like anything like do concrete equals stud any cast of my struct, taking a pointer to anything. Can I cast this now to a reference? I forgot what the semantics are on this. Oh, it's a pointer, right? It's a pointer. So it's something like this. Yeah. So I think, so if I do this, this will return to me a my struct pointer. So I need to dereference the pointer because I know what this is. And then I should be able to do something like concrete set x 50 concrete print return 0. Let's see if this works. Yes. Okay. So this is, so I just want to make sure that I know how to get a reference from an any. So this is the syntax where I start with something that's basically completely type erased, like this thing can hold any type, and then I just cast it to the right type as a concrete discrete objects. I wonder if Anycast is actually, I think Anycast should be, might be wrong about this, but I think it should be, I wonder like how different, like, because if this has dynamic cast, this is a little bit slow. I probably should find another way to do this, but I will keep this as a simple way to prevent the implementation. Then later, I will do something that prevents this dynamic cast on every single call, which is going to get annoying. Anyway, so now that I have this pimple, when I create it, I can always do something like get concrete pimple. Let's how am I going to do this? Let me put put this as a template in the interface actually, because I don't need to expose the type here. So I can just do something like template type name t get concrete, and this is going to be just returning. I just don't need this. Don't need this. I just need to return something that references this on the pimple with that T. Yes. So I just created this helper function that's going to help me kind of reach for the actual implementation whenever I need it, but without putting the type in the header. Now in the implementation, I don't need this. I can just do something like get concrete. Let's make some simplification of this, something like using RT equals RT audio device manager. So if I just want to reach for the RT, I can just do get concrete RT, and then call a function. In this case, I think the function here is not public, but it will be pretty soon. So I can just go here in this now exposed device manager. And this thing does have all the implementation details, but stuff like yeah, so I think in this case I just need to reach for the manager because I didn't put it. So it should be something like dot manager, right? Yeah, I can just remove all this private stuff because all of this stuff is private as far as the user is concerned. Yeah, this should be a decent start, I guess. A little bit too wordy. A little bit too wordy, I guess. But we'll see. We'll see. I'm gonna start with this just as a starting point, and so this is gonna be something like this, right? It's gonna be like O2 manager equals this. Why can't I reach this function? I want to do some periodically checking on my Discord to see if the world is exploding. How's everybody doing? Are everyone watching this? Everyone have some questions about what I'm doing and why I'm doing it? I'm working on this wrapper library, or on this audio driver library that's currently wrapping RT audio with what would hopefully prove to be a cleaner interface. Yeah, so actually what I need to do, probably most of these functions that used to be public don't need to be public anymore. Yeah, let's change this. Let's go back here. What I did was, yeah, everything here that's basically everything here that used to be public can just go away. Yeah, let's make this clean. Everything here in the RT audio device manager that used to be public is Let's go away, and I just need everything that used to be private. Yeah, and this function probably does not. Yeah, so I'm storing the config, and then I'm doing a bunch of stuff, right? Interesting. I have some naming problems here. I think I need. I need something to communicate between this nice interface that has clean types and the implementation. And I could just wrap this in a base class, I guess. Maybe this would be the correct way to do this, just do a base class. Just do a base class and have a bunch of like exposed functions. Because this error stuff, that's interesting. I'm not sure how to construct this interface. This error stuff, the error handling stuff, I wonder if I should be exposing all of this. If I should be exposing all of this in like some, maybe I should. Yeah, maybe I'll do that. What do you think? Remember, let me know in the comments, the comment section, where if you have any questions or something like that. So, I'll go back to how this was before I changed this. I just had this implementation. This pretty much looks exactly like my implementation. I might remove this. I might restart this thing. Yeah, let's not do this right now. Let's wait with an intermediate step. I'll literally will have all these interface classes with no. Yeah. I'll just do something where the implementations on the public functions will call the public functions that already exist on the other side, and then I will start to move this once I have a solid base, because this is, I feel like, too many details to move at once. So what I will start by doing is I will have all this stuff have pretty much empty implementations and just call forwarding. So can I have auto implementations of this, like create definition? Is it going to go to the right place? Well, I can just move this, I guess. So I'm just going to get all these yeah, so I just ask it to kind of autocomplete all these functions. Let's go to the implementation file. So let's start just with forwarding. So this will just create a new RT audio device manager, or RT. It's just going to be the RT. This would do the destructor. This one is interesting because I actually probably need to move stuff over here. The destructor does stuff like stop audio, all this stuff belonging to the interface. But I'll start. I just have it as an empty placeholder. Get devices would return get concrete RT. Get devices. Yeah, and this just is going to be the pattern for now. Just get default input device. get default config, right? Set config. Start config to use callback. And I'm just forwarding all these functions basically as the first of multiple cleanup phases. Right, this is it, and this is get stream separate. Okay. Yeah, and I think the destructor is fun because there's currently a destructor in the implementation. Let's see if this works. Oh, pointer to a pimple, right? Yes. Ooh, something was did not work. Why? Turn. Oh. Interesting. So did it forget the creation? Did I? Because I thought I did create this correctly. I thought that in the constructor I did this. I thought this was correct, right? And this is called, right? This is the right thing. So yeah, so this should call, you know, the actual object. Probably shouldn't be using studany for this. Manager, right? Or there's a manager here. But it looks like something was not initialized. Like the constructor was not called or something. Does it make sense? Yeah, the constructor for the internal device manager was called. So what is the problem here? Why do I get? It's probably some indirection thing that happens because I screwed up something with the any, the use of studany, right? Stud anycast t, right? How did I do it on here? I think I did the same thing, right? What is this bringing? Oh, you know what? I forgot to do this. That's interesting. Yeah, well, this works in the console app. So I think I've done this correctly, right? This returns a mystruct reference. Any cast of this, right? So how did I write this helper function? Get concrete. Reference of this. Take the pimple, which is studany. Turns t reference. That's interesting. Right, T. It looks good. What did I screw up? Probably screwed up some ampersand there or something. What did I screw up with these it's just something like O2 concrete equals let's just do something here like this, just so I have a breakpoint. See what this does. Was this not initialized? Did this just not work? Maybe this thing should be on the heap, and maybe I should do something like this. So I should do something like stud make unique of RT, or make shared might be better. Make shared because this needs to be copied. Yeah, maybe there's a copying that happens here that is not right like that. I probably need to you have some pointer semantics. So it's probably better for this kind of thing. And then when I do get the concrete, To make this fun, I would need to double dereference this. Dereference the any and then dereference the, oh, sorry. I need to get, no, I can't just dereference this once, but I need to get this as to shared pointer. And yeah, I think this would be like this would give me like a pointer to a shared pointer. So I think I need to dereference this twice, as weird as this sounds. Let's see if this works. See. RTAPI. Oh, look, I have devices. So I think this is now going good. So now this did not crash and it played the sound. Okay, so I'm going to start with this. Just have like a commit that works before I will clean this, because this is quite horrible. I don't love this. What did allow me to do is I have now a device manager class. This knows. Yeah, I don't need this now. I don't need to include device manager at all. I just need to include device info, which with my types and std any, right? Let's see if this still compiles. Oh, I need to have optional, I guess, somewhere there. Okay, good. So device manager info needs to include optional, and probably need to include string as well. This will clean this up. What else? Function. So function comes from functional. Good. Now that I removed RT audio from this include chain, I actually have to have a more explicit include chain from what I'm actually using, and I hear sound, and this is great. So now, hopefully, you're hearing this white noise, and I'm playing. This is the minimum like sound that I get my app to do. So I think this is better. It's not perfect. The idea of how this works for now is that as a user, right? The user is this example app. The user does not have to include this particular implementation. I will be able, like if the user will include some other implementation, this will work with that other implementation as well. It's still using this std any way to kind of communicate this. It's not perfect. I'm going to make something better once I clean up this API, but std any is very convenient in that sense. It's just very easy to do something like an unincluded type in the header, and then kind of make this be used in the implementation. Okay, so I'm going to commit this, and I'm going to call this moved RT audio device manager to be hidden behind an implementation file using std any. Okay, so that's step one. Let's see what's next. Now I need to really clean this up because I did like a very I moved a bunch of stuff into the RT audio device manager that actually do belong in the generic implementation. Like there's actually, let me give you an example. The destructor called stop, right? I don't think like this is logic that's specific to RT audio. I think this is fine with the generic thing. Same thing with this logic about like getting the devices, creating like a vector. All this stuff should probably belong in the public interface, and there should just be forwardings of these calls. So let's start doing some interface mangling. So I'm going to start with the error one. That's interesting. I have not decided what to do with this error handling version. I might want to move it. Yeah, let's start with this, just so that I'll do those one by one. So the one thing I want to do is let's think. Yeah, let's start with this. Stop. Stop is going to be easy, right? So I don't need this destructor. Probably I can just use the default destructor. Instead, the generic implementation, right, should just call stop. And I think I have a function called stop in the public interface anyway, right? Stop just forwards a stop call, so there's no problem to make this separated. Let's continue. What else? Get devices. Yeah, so all this stuff, like, there's nothing other than, I guess, yeah, I think there's almost nothing here that is unique to RT audio, because I think I've kind of got all the stuff out except for this thing. So I'm going to start by let's start by taking this implementation into the interface. It's called get devices. So instead of forwarding to RT audio, I'll do my own thing. I don't need this extra scope. Get device ID. Maybe this is a function I should be exposing. Yeah, sure. Or at least I can do this as a private function. So I can do something like, what's get device IDs? What's a get device IDs? Vector of unsigned ints. I guess. I don't know. Is this too specific? Is this too specific to RT audio? Like get the IDs? I don't know. I could expose this. I could make this like the question I'm asking myself is get device IDs something that's going to be needed for every implementation? That's really the question. You know what? Maybe not. Maybe I'll keep this the way it is. I'll keep this in the RT audio implementation. I think for now, like I don't want to make this decision of exactly how other backends are gonna behave. So I'm going to remove this. I'm going to keep this as being a forwarding call to the concrete. Let's see what else. Next is get default input device. All this stuff is just forwarding calls and kind of like forwarding calls into the thing and converting, and this get info call, which is like a conversion call that I made to convert the RT audio type into my type. So there's just a bunch of conversions. This, however, get default config. This stuff should not belong here. This stuff should totally belong in the interface code. Like there's nothing about RT audio here. This is just a helper I made that might even be a free function. I don't know. But this is I guess the main idea. It's like some public function that helps users to get a simple config. So in this case, this is not needed. Set config, same here. This belongs in the interface. You can just remove this. Set config, right? This is all my logic. It calls open stream and start stream, which is our functions I probably should have here. So I'm gonna keep those red, so I'll keep remembering to implement this in a second. Same here. Start, stop. All these functions are not relevant to RT audio. They're relevant to my code. So this is stop. What else is here? How's everybody doing today, by the way? I'm not hearing a lot from the comment section, maybe because it's early. It's a weird hour. Definitely let me know what's going on here. How are you doing today? And if you have any questions. Okay, so I can remove this stop implementation here. Yeah, I think that's better. But there's still something about this open stream. Yeah, open stream, that thing is pretty... Yeah, so I should have a forwarding call for open stream. And I'll keep that as a private function, but still like a function that just forwards to the get manager pimple. Open stream. That means that it doesn't need to be public here. Set config. Oh, that's weird. Why did I put this on? I'm out today. This is a part of start. So where's the part of that I need to stop? Or do we stop just to stop, right? No, I had some actual code that did stop. I'm totally blanking out here. Where's my yeah, this should be the real implementation here. Yeah, so stop does need a few things I need to expose from the implementation. Is stream running and is stream open? I guess it's fine. But I don't know if I love the idea that, yeah, you know what? I can just keep this as the implementation. I might not need to. I could just use whatever. Just keep it, because close stream, stop stream, all this stuff are probably just specific to RT Audio. I'm guessing, maybe not. So maybe I will just keep avoid stop here. Yeah, and then I'll just forward the stop call. Okay. Open stream and start. Okay, so there's actually should be. I probably need to start. I need to start call because all this stuff will probably be turned into an interface that will have a few different backends. So having a currently I separate open from start. I guess that's what happens here. Right? How do I do this in my code, in the device code? I do something like open stream. So I first do open stream, then I do start. I really wonder if I need this. I'm just gonna keep this as it is. I just for now have open stream itself. Just call start. Yeah, so for now, I'll just do that set config and start are kind of intertwined. They're the same call. Okay, let's see if I'm good, if I'm compiling. Good, compiling. And I get no sound, so that means I missed something, probably in this flow of open. What am I missing? Okay, this isn't called, so I forgot to call. I'm calling set config on my device manager implementation. I just like set config. I just stop, and then open stream. Or maybe I should just start. Yeah, start. That makes more sense. And then I can just have start. There's some confusion there. What's doing what? Set config is calling. Yeah, so I probably don't just. Maybe I just don't need to. Oh, because I can just store the config here, like config equals config to use. And then just start. Oh, but start also takes the config. This is confusing. Yeah, this needs to call OpenStream. Config, I guess. It's kind of weird. I need to do this. Let's make, if this is a private function, let's remove the requirement of config because I already have it. And I can just use the class member config that's already stored and stop an OpenStream. So start is going to be a public expose function, and then it's going to call OpenStream. How's everyone doing in the comment section? You're pretty quiet today, or maybe it's my app that's broken. Hoping that my audio works. Check if I'm working. Am I working? Not yet. I'm still missing something. So the user is calling start. Right, start is fine. It's calling set config. It stores the config like it should. And then it stops. Oop, what did I do? Let's do it again. Stop is calling stop, that's fine. OpenStream is calling OpenStream. It stores it again, which kind of makes no sense. Yeah, right. Why does it store it again? I guess because it has to use it in the callback. I guess it's fine. I don't mind. It's great. Calling start stream. Yeah, so looks like it worked, but my sound is not playing. Let's see what happens in my example app. I have the example app. It should be calling this process block. See if that's called. It's not called. Called start. Start is doing set config and OpenStream. So I missed something in my previous implementation here. I thought calling start is fine. I thought finishing this, doing all this conversions and then calling start. Should have been enough. Let's see if maybe I passed like the wrong, maybe there's like an error. Maybe I passed like the wrong configuration or something. It's possible. Okay, my OpenStream is not called, so that makes sense why no sound has been played. Let's see why not. So in my device manager, create.openstream. Let's see which config that I pass into this. So the input, device ID 142. The output is device ID 142. I think device 142 is what I should be hearing. But I guess that I missed something here. I wonder what. Doesn't look like I'm storing the config. I'm stopping it before I'm starting it, which I think makes sense. Right, stopping, we'll check if it's running or open and then close it. It's fine. open the stream. It's weird. Everything looks correct here. What am I missing? What did I just change that makes this not work? It's not throwing. I wonder what that is. Also, why are my breakpoints not hitting? Maybe I'm building like the wrong code. Let's rebuild this for a second. Ooh, look at this. Non-portable path. That's interesting. Okay, so this should be RT audio. That makes sense. So that's the bug that I had with my breakpoints not working. But that's not the bug that I had with the config not configuring. So I'll call this with this default config, which should be correct, I'm hoping. Get default input device, get default output device. Something is screwed up in here. Maybe the copying, maybe something in the copying of this config file, but I don't think there's pointers here. Like this, everything here should just be copied in a very simple way. I don't think that should be a problem. There's no like crazy semantics here, like crazy reference semantics. Maybe I have another way of calling OpenStream. No, it's just called from setConfig. SetConfig stores everything and then calls it directly. What could this be? Let's see the config that I'm returning here just to get some idea. Sample rate, block size. And basically everything makes sense, right? I wonder what this could be. Where is this thing? Manager, get device info. That's interesting. What's wrong with what I'm doing right now? Still have the CVP file. It's not needed. That's so strange. Although my app is kind of freezing. I wonder why. I think this should already stop, right? Like in my example app. Oh, no. I should let's have it not as a while loop, just see that it quits. So just play this for 3 seconds. Okay, so it doesn't quit. Something hangs in what I'm doing here. Maybe I have some, so let's do some pause program. Oh, here you go. So I'm calling stop stream. And stop stream. Oh, maybe I have some recursive call here somewhere. So I called stop. Right? Let's see what this does. Like, is this this is oh, okay, so this is waiting on some mutex, like internally in RT audio. That's interesting. Why did it not happen before? Okay, so this happens in the destructor. That's interesting. So when it tries to destruct itself, it's kind of looping infinitely for whatever reason. Oh, probably because maybe I didn't. Okay, so I'm guessing. I think I know what happened. Okay, so what am I gonna do? I think what happened is the way I opened the stream in this wrapper, which is probably here. Yeah, so I do open stream. I think the fact that I called start stream from here directly, I think this is a problem. Not sure why it's a problem. But let's just run this and see if this doesn't hang, just to give you some clear idea of what happens. Yes, so this is fine. This doesn't hang. Doesn't start the stream, because the stream probably needs to start after this returned. I have no idea why. Why do I need to wait until OpenStream finishes? Maybe I'm creating some stack object here that waits until I'm finished. RT audio error type. Maybe there's no. It all looks like plain type. So why would I have some scoping here that makes me freeze forever? Not sure. But just to see that I know what I'm doing, let's go to my implementation, and I'll start this OpenStream, and then let's do let's just have for now, I'll have some void start or something. Start stream. Let's finish this and then do get concrete start. Or I can just, as part of OpenStream, do this and then start. Oops. Yeah, it still hangs. This looks like I'm not supposed to be calling start directly here, but I thought that was about what I was doing before. I thought, if I'm going to roll back on this command, I think my previous version was doing exactly that. So let's look exactly what I did in the previous version. Let's look at my Git history. Sorry, let's do yeah, it should be the history. I should just see. Did I not make these changes here? Where did I make these changes? Maybe I changed it in here. History. Just to let everybody know, first of all, my name is Eyal. If you don't know that yet, I'm making a wrapper library, like a driver, an audio driver wrapper library in C++. And now I'm trying to find some bug that I probably introduced 5 minutes ago. So I'm trying to find exactly what it is that I did that's wrong before I roll back and compare it like this. Definitely let me know in the comments if you have any questions or comments about what I'm doing. Okay, so I need to realize what it is that I did that introduced a weird bug. Like introduce something like, so it's something in the order of how I was calling. It's probably here. It'll be right. Is here I'm going to see the history of what I changed. History. Okay, this is the device manager, and I need the implementation file. It's weird. It's almost like it's not here, and I'm not sure why is it not here. Let's see if I can do the diff. Okay, so I had an OpenStream function that I moved from one place to another. I guess that makes sense. And I had a stop function. I had a start function. How was I calling these functions? I had Interesting. Probably should be doing this, even though it probably doesn't matter. This is also kind of weird. Oh, wait. Okay. Okay, I'm so silly. I completely forgot. Now I realize what is wrong with me. That I now have this like double bookkeeping, and since I have an internal class, I didn't pass the callback into it. Now there's this class, RT Audio Manager, and that thing holds. Yeah, that thing holds the callback and the. Yeah, that's not good. That's not very good. And there's some additional bookkeeping here, which doesn't make sense. Yeah, there's some weird things happening. There's some weird things. So I think the bug will be fixed temporarily by doing this. I will go to the device manager implementation, and when I do OpenStream, for now I will do this. Callback equals callback. It's kind of silly, so it's not going to be the good solution, but I'll just assume. Good. Now I get sound. Okay, so I fixed the weird bug. Let's just commit this and start to make a better solutions now that I'm out of weird bugs mode. So let's do something like start moving more functions into the interface of the device manager. Okay. It's not so clean what happens here in the implementation. Let's have a couple of more looks before I do such, but it is better. Like what I just did in the last, since I started the stream, I was working so that this will be a clean interface, generally with just a few public functions. There might be a few more added pretty soon, and yeah. Now I just want to remove a little bit of the bookkeeping from the RT audio implementation, just because some of the stuff here are not really about what it's doing. Like there's something here that says, yeah, compare the info. Like that thing, I don't need this thing. Like this totally does not belong in this code. All this prev info stuff. I can probably remove this. And I kind of need the config, because the config kind of needs to be stored around the class somewhere. So I guess I need that. But I definitely don't need the... I guess I do need the callback as well. Just kind of... But this callback... Yeah, but I can make a callback that's different. So what I can do is have all of this. Manager.callback, blah, 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 blah. Yeah, get callback info. And then... Where is my, yeah, because this is fine. This is just converting the type. But this, yeah, this would just be, should do something like callback. Or manager.callback. Info, and then return info.error code. And this stuff can probably move into my code. My code, or this is all my code, but my interface code, instead of doing this, I can just create like an actual more meaningful callback here, and that's actually going to be pretty important. So let's call it actual callback equals cb or callback. How's this thing called? Or I can just do this, I guess. And here I should store prev info. I'm already storing this. That's good. If the info is new, and then trigger the callback with the current info. So this is going to generate a new callback that we're going to be sending, because this callback, the raw callback, does not have this thing, the previous info, blah, blah. I probably should go, I'm going to do some wrapping around this thing pretty soon, so that's slightly more convenient to use and will help the user to use it. But let's start with that. Okay, very good. Still getting sound. So moved some bookkeeping out of the RT audio implementation and into the public shared interface. Okay, that's good. That is pretty good. Okay. How's everyone doing out here in the comment section? I don't hear you enough. Let me know what you're thinking, what your questions are. I think the first thing I'm going to do is I'll probably add a little bit of maybe thread safety in this. So currently, let's go to my example app, right? That is, if the user is doing something like this, right? They do start, get default config, and then they change the config. Like they want to, user wants to change a sample rate. This is something we worked on in the previous stream. That thing is just going to happen. Like there's no safety in here. The user will probably try to change it from the audio, from the UI thread, or some other thread that's not the audio thread. And it doesn't make sense. Like we don't want the user to start having race conditions, because when they call this thing start or set config or whatever this thing is called, this is going to this will collide. Like this actually stores variables. Those variables are actually touched in the audio thread later. So we need some protection mechanism there. And generally, the way we probably would have to do this is by using a lock of sorts. I could use something like a std mutex here. And a std mutex would technically work. And it's probably fine actually to use a std mutex here, because if I'm calling this, the sound is actually probably going to be stopped pretty soon after. So I'm going to start with an implementation that does use a lock here, but I probably need something more real-time friendly, like maybe a spin lock could be okay, I guess. Or I don't know. I'll have to think of like what kind of lock would be good here. Like usually the way to do this stuff is to do lock free, but this is only going to be in contention when you're changing something. Yeah, because what I need to basically, I just need to protect these public functions from being called at the same time, especially all these functions like set config, start, and stop. Yeah, I think those need to mostly be, most of those functions need to be somehow protected, because we're kind of expecting. And you know what? I might even not. I could actually try with moving these some of these to be private as well. So it's just these three functions: set config, start, and set config and start are basically the two functions that call each other. The only thing the difference about set config is that it allows you to use a previous callback. Like you can change the config and still rerun the callback. It's possible to also do like set callback, like kind of have three different, I guess, variations of this. But anyway, all of those will probably need to be protected as well as stop. As well as I guess as well as the audio callback itself, right? The audio callback, not this thing, but the callback, but the kind of callback that I'm generating, which is this thing. This probably needs to be protected because we want to make sure that if that if the user is setting some callback, well, that's interesting. Yeah, because there's also something I need to set up in RT Audio itself, probably, right? Because RT Audio also has a callback that I'm setting, which does a few little things with the config. That's interesting. Like, does that fully protect me in terms of like threading and race conditions and stuff like that? I'm going to start with a rudimentary solution. This just puts a lock in a few places just so that I'll have it, and I'll run some tests later with thread sanitizer or something to see if actual race conditions could apply. I still think they could apply, right? I'm changing the config. Yeah, I also will need to lock this in the underlying implementation. I don't love it. Because if I go into this function, this is just some multi-threaded classic problems. If I go into set config, right, the user calls set config from the UI, they call this. I can lock this, right, put a lock here, do something like a stood lock guard right here at the entrance. And I can also, and this is a function that could be called, right, at the same time. And I guess if I put the lock there, this would make sure there's no other callbacks on my end when this happens. This would kind of ensure that it happens. But I do wonder, by the way, if I call this 3 times, I should do something like O2 RT equals this thing. No reason to do this 3 times. 2. Oops. What's RT? Yeah. But I wonder if doing a lock in here would actually protect me. Because if I put a lock here in this entrance, this is actually called by a couple of other classes here. Like there's the RT Audio class. And there's another, I guess, underlying element here where this thing, audio callback, like this function actually is getting called. Let's have a look. You know what? I'm just going to breakpoint here to see how this looks like when it gets called by RT Audio. So this is the stack that I'm getting. You see, I'm getting a handler. This handler is something that gets called from the device somewhere, I guess. And the device is calling this callback that RT Audio registered, right? There's probably some calls here. I haven't looked that deeply in the code. Something about threading. condition signal. I think this condition signal is kind of something like a lock, right? Let's see what's pthread condition signal is. I'm guessing it's going to be a lock of sorts. Oops. I'm guessing it's going to be a lock of sorts. Let's have a look. Get out of here. How am I going to get the this? So pthread condition signal. Okay, pthread condition signal, pthread condition broadcast signal, or broadcast a condition. These two functions are used to unblock threads, block on a condition variable. Okay, so this is exactly like a lock. So this locks anyway, right? There's a pthread condition signal. Basically, it locks on some mutex, I guess, right? Handle condition, pthread condition T. So I'm guessing this is like a mutex. So yeah, it locks on some memory address or something. Kind of weird that this isn't an atomic or a volatile or something weird, but whatever, I guess. I don't know. Callback event. And I'm guessing this is going to be called in other places as well. Close stream, yeah, exactly. So they locked exactly in the same places, right? They did there's some horrible go-tos in there or whatever. Start stream, stop it, right? So they did the same thing, I think. They used this this locking on a condition variable in all the different places where this could collide. So perhaps I shouldn't be as worried about locking this. I do need to lock my own code because there are probably some, like if I call set config, do I do something with this config? Probably not. No, I'm not doing anything with the previous config. I think that part is fine. If I'm stopping, yeah, maybe I'm not changing this, at least in this class. Maybe in the implementation class with the RT Audio Device Manager class. Yeah, so OpenStream stores a local config. And then, am I reading this later? Yes, I am. Okay, so here I should probably be doing a lock. Yeah, let's start with that. Let's start doing a lock here. I can probably do this around some spin lock as well. But I would just try doing this around a stud mutex. So I can do something like here. So I would do something like a stud mutex. I'll say hi to Samarthina or Yolanda joining us. Hello to you. My Hawaiian hello is not as strong. So I was just trying to think of what would be a good locking strategy around this. And what I noticed in the discovery was that RT Audio itself does lock around all the imported calls from what I could gather. But I do probably need to lock a couple of calls because I'm doing stuff like storing the config and then reading from that config. And I think that's dangerous. Like that could collide. So I need to protect this kind of call, like OpenStream, where I'm storing this. So I should probably do something like void set config. Oh, you know what? And I'm also changing this. Like this actually gets changed during OpenStream. So that's an interesting question. If I call close stream, right? Is close stream guaranteed to return to me after I call this, or is this like an async close stream? Like if I call this, am I guaranteed to have free let's call it a free spirit way to do this? Because if that's the case, that's probably very useful. Like I can just say, okay, well, close the stream. I'm going to wait. Let's see how RT Audio implemented close stream. It'll be interesting before I start locking with this, because it's possible that I can just kind of assume that because I called close stream before I opened a new stream, which I did, it's possible that I'm guaranteed to not have any collisions, right? So let's see this. Let's see. I am probably calling close stream here, right? Let's go to my example code and do go back to my version that changes something. So the way I changed this thing, I wanted to I just copy this default config, make a sound default config. Let's call it a get config. Int block size, or make a sound device manager and block size. And all it's going to do is to default config equals manager get default config, and I do something like block size equals block. So that I will be able to create a few different configs with different block sizes. I can probably make this easier on the user later. What's this? Why is this yellow? Oh, because I didn't return it. Return default config. So I'm just going to do, let's get a config manager. I don't know, 512. Let's let this run for 3 seconds and run it again with another config. So I'm going to start it again with 256. And what I'm expecting that will happen is that I will get a call to stop this. Like we get a call, because when I call start, it's called set config, which first of all is going to probably before this should stop first before it sets the config, right? And this is interesting, because what I'm trying to figure out, is this synchronous? Is this waiting for the audio to stop and then letting me set it up again? Or is this kind of async call where it calls to stop but returns immediately? Maybe I can find it out from the documentation, but I can probably verify this. Let's see what they say in the documentation of this library. They say, this is the implementation, but there should be an interface here. Okay. Stop the stream, allowing any symbols remaining in output queue to be played. Okay, so if I understand correctly, this does let it play in an async way. So I can, how would I know? Oh, abort stream, that's interesting. Okay, that's another way. Discarding any samples remaining in the input-output queue. So maybe this is better. Maybe abort is, maybe abort is what I need here. Does this say anything about, like, is this returning, like, what's the threading model in this? What happens when I call these? Oh, wait, there's close stream also. It closes the stream and frees any associated stream memory. Maybe this is better, because this frees all the memory. This maybe is more guaranteed. Yeah, let's try this. Let's try close stream instead of stop stream. Let's see what this does. So currently, yeah, let's try this. First of all, I'm going to, when I do the stop call. Okay, so I am doing stop and close. Yeah. I guess I did because the stream could be somehow already be stopped, so I could stop it. I don't know if I need these two if conditions. That's an interesting question. Okay, so what I could be doing, I guess. Okay, so I'm gonna start just trying what I just set up. So I'm gonna set up the config, wait for 3 seconds, set the config, wait for 3 more seconds. And what I'm trying to see is that I kind of want to follow what this, especially both the stop and the close streams are doing. So let's see what they're doing. So starting, I'm getting sound, a few seconds, and here's the stop call. Okay, so this does stop. Let's follow this along with the implementation, right? This calls, by the way, a specific implementation for core audio or something. Let's see, the core audio, like the Apple driver. Condition wait. Okay, so this waits block. This waits probably for the process thread to finish. Audio device stop. Okay. Yeah, so it does look like it stops everything synchronously, is my understanding. So I stop the stream, and then closing the stream will probably do the same thing. It'll be interesting to know if those guarantees happen in other backends, but this looks good to me because this means that I should be safe from any threading problems. I believe. Because the main thing I was worried about is that I probably can remove all these mutexes. I think this should work. Again, I probably need to run thread sanitizer on this to see that this is really the case. But I think that these classes, what do I call these? Yeah, I was worried about something like this. No, not this. I was worried about this. Callback and config. I was worried that these two could have a race condition between the audio thread function, which is this. This is the audio thread like callback, which is called by the driver, and this reads from manager.config. And I was scared that manager.config could be read from, while this thing open stream writes a new stream. I was scared about that. But this might not be the case. Like, it's very possible that there's some that what I did was fine, because I think there are guarantees now, especially with close stream, that after the call to close stream, it does place like all these pthread locks in there anyway, until audio is stopped. And I should be then free to use the config freely right when I set it again, because when I set it again, that's why I did this. I said, because the UI is going to call this with a new config, with a new buffer size or something, or a new audio device, and I think by then this should be okay. So I'm going to kind of decide that this is enough for what I'm doing. Yeah, I think this should be good, right? Let's do I still have a breakpoint running? How's the audio, by the way, everyone? Is the audio fine today? Let's try some other way to connect everything. Okay. So I'm going to commit this and say that. Let's go through what I changed. Yeah, so fixed audio callback. Fixed audio callback passing issues into the underlying RT audio backend. Okay, so this is better. I'm going to drink a cup of water or a bottle of water, and then I will do some serializing. Any questions, Ronan, so far? Okay, I'm glad to hear that the audio is good. Yesterday I had some clicks and pops because I had some weird... I basically had the world going into my Thunderbolt splitter, which I guess works for the general case, but not for the stream. Like it was choking up with both the camera and the monitor and the, I guess, audio interface. Everything was going through it, and I think it choked at some point. But yeah, let me know if you have any questions. What I will just be doing now is what I'll be doing now is I'm starting to, I need to have this thing serialized. Like I need to make sure that there's some layer that takes everything that just happened here and puts it in like a JSON format, JSON file. And basically what I need to be serializing is this thing, device info. Like it's a bunch of generally primitive classes. In my code, my code for Modalix, I have a lot of helpers to do this. Like so what I'm going to do now would probably be way more typing than I usually do. I might bring something like magic enum as well. See if I can what's the licensing model on these, because using those will probably be pretty viral. So Loman JSON is a great library that's MIT licensed. I think I should be fine with MIT, I guess, for this library. And then what's magic enum? I would like to bring that library too. It would help a lot. Yeah, it's MIT as well, which I think I probably should use. I don't know how many. Is there anybody here who knows things about licensing? But I think MIT should be permissive enough, right, for just general people to use, right? I think that's usually a good license that should give you, like, I guess almost everything in terms of commercial use and stuff. I don't know the full details of the MIT license. What I'm doing is I'm just reading a little bit about this library. I really like this library. It's called Enlohman JSON. It's a very cool JSON library that I love to use. Yeah. Okay. And actually, this will be a good chance because I know how to use Enlohman, whatever you say, in general. But it would be great to learn a few different things. So what I'm going to do is I'm going to bring in two libraries. One is this Enlohman JSON, and the other one is Magic Enum. Magic Enum is just a great library to convert enums to strings. I have a few enums here. It would be nice to not write this stuff manually. Yeah, so let's do that. So what I'm going to do, I think Llama JSON has a way, which I've never used before, but I think it has a way to pass a struct into it. Yeah, arbitrary type of. I've never used this thing because I have my own library usually that I'm using for this. Yeah, here, this thing. This is probably what I need. SCL. Really, you just need like one of these lines. Okay. Convert to JSON. P-name from JSON. It works, but quite a lot of bull. But fortunately, there's a better way. Create a person. Conversion. Here you go. Okay, this is what I need. This conversion thing. Yes. So I'm going to learn how to use this on the stream because I have my own library doing something kind of like this, like what they're doing, which is like a less boilerplate way. Do they have something like a magic enum kind of included? I wonder. Well, enum JSON is integers. Some way this could result in undesired behavior. Okay. This is how I give an enum map to and from JSON. Okay, this is like a manual. Yeah, so it does look like, yeah, but I think for now I would use magic enum and a llama JSON for the serializing part. Okay, so what I'm going to do is I'm going to add, first of all, add these to the, I could add these to the fetching, I guess, or I could just like kind of inline copy these. Let's think. What would be a nicer way? The only thing I'm scared about is some of these libraries just do a lot of things in their CMake file. RT Audio is very nice. Like it doesn't do anything that takes time, but some of these libraries do some, like they run all these like tests as part of the build configuration. It's very annoying. But I would start by doing, let's start by just doing it straight up. So I'm going to do this with, so let's start with enlom and JSON. Where's the code link? Oh, I think I just need to do enlom and JSON, right? It's called master. Master, okay. This master is still being updated. Is this, yeah, okay. And then let's start with that. And then all I have to do is come to my CMake list file and do find package. Oh, whoops, I'm confused. I need another find file for this. So what I need was just another file called find. I'll never be able to spell enlom correctly. Find enlom JSON. Let's do it this way. And this should just be, oops, rename .cmake. It's better. And now this would be Loman JSON. And what this file does is it's a file that will help CMake help me do this. And Loman JSON required. And when I did this, this will kind of tell CMake to use this file. This is also a nice way because you can also supply your own scripts to do this instead of bringing it from GitHub like I did. Okay, so this is bringing JSON now. And I'm not sure I'll do it this way because this is quite an involved process, I guess. This already takes too long just to clone this library, so I might immediately not go for this kind of package management just because it's just going to be so annoying to interact with. So I might just copy their header. They have a single header. Yeah. And this says that serialization would be so much easier with reflection. Yes. Yes, that thing is, even though I would say that there's complications with using reflection for serializing, because stuff like names of variables could change and then your JSON file would change, and that's not so good. So even though it would, I think reflection would make it work for basic things, it might be a little bit error prone. Because using the names of the variables is like a good default, but when you think about, like sometimes you're writing something, your interface changes, but you want to be compatible with presets, I don't know. That's kind of like you would need all these like manual injections of reflection functions. There's going to be complications even when this is going to be an actual feature in C++. Yeah, so I just did that, but it did bring in Loman. I'm going to keep it like this for now, but I'll probably change it, so we'll see. So I got this, and I will also add another file for find magic enum. .cmake. And it's pretty much the same thing, just with new guy magic enum. And the name of this is master, okay? And then I should be also do and now the config of CMake brought it brought all of these, right? Did I get magic enum? Magic enum. Yeah, I got it. Okay, good. Magic enum kind of was brought instantly, and Loman JSON was slightly more involved. I don't know why. Okay, so this should allow me to do let's see if I can just link against it. What kind of interface are they bringing? So I should be, let's start with my, just link the example before I do something in the library. Let's do something like, let's do something like, make a sound and connect with nloman JSON, right? So let's see if I got it. And if I link against it, I should be able to do something like include Loman JSON. And I think this should allow me to do something like this. Should allow me to do something in my main function. Like I should be able to do something like if I do a std vector of string. Let's see if it knows how to do that. Vector of std string vec equals to hey hello. And I should be able to do return or std cout something like nloman dump or just JSON dump. I think I should create it first. I think I should just like create something from vec.dump for. See if this works. Yes. Okay. So this serialized perfectly. It took my vector, serialized into a string. That's awesome. So this is what nloman does. That's why I love this. It's got a very, very nice interface. I think I should also be able to do something like a std map of std string and std string, and then do something like map hey equals hello map my value equal my key. Oh, I just realized that all this time I just had my screen. I did not have my screen. I was just coding for myself. Nobody told me that I was not. But basically, what I did in the last few minutes, instead of showing this on screen, because I was not paying attention, is that I added. I worked on the CMake file. So I'll guess I'll roll back a little bit. I worked on the CMake file and I added two find files. They're just files that will say that if I go here to my CMake list and try to look for magic enum or nloman JSON, these files will be called And in this case, it will go to GitHub to find those packages. So that was the first thing I did. There's no secret stuff here. It was really just package management without me doing. I was just being not aware of what I was streaming. Okay, and then all I did was when I came here, I did find package and lawman JSON and find package magic enum, and this would trigger my scripts. And then I would I linked against them, and once I linked against it, I could do something like this. This is so nice, right? Yeah, so I think it says, personally, for config purposes, I find YAML much prettier than JSON. A lot of unneeded character noise is no issue any longer, and the format is very concise and has comment. Sure, I mean, I'm sure somebody can make a YAML format or something, but this is not because I like JSON, but I think because JSON is already, like for example, a request that I got from Julian Storer about this is that they said that they want this to work with a JavaScript front end, right? And I think JSON is just so much more widely used in many languages, and most languages like Python and whatever would have like built-in JavaScript, built-in JSON parser, and so I think JSON makes more sense as whatever I'm going to offer in my library. But if somebody wants to make a YAML display for this, I think that's fine. Like I don't think one of the things my serializing library does for Modalix, which maybe I'll make open source one day, is that it lets you very easily reflect on these complicated objects and serialize them, but it doesn't specify a backend. Like you can give a backend, you can give a JSON backend, you can give a YAML backend, you can give an XML backend or a juice value tree. So there's all these like backends that are, and your actual serializing code is kind of not aware of this. So if you wrote some special serializing code for your classes, it will work with all these backends. So there's some advantage there. Here I'm going to be manually writing JSON because I just think JSON is so nice to use. I use it so much, and it's even nice to use raw, in my opinion. Like it's nice to code into it. It's nice to load it into another language, etc. Okay, so all I did was I wanted to see that it can serialize. The enrollment can serialize this thing, a map of a key of strings and value of string, and let's see if it can do that. Yeah, so it worked on this really well. Here it is. Hello, my value. So this worked. It managed to work with the types kind of by default. Let's see if I can do what happens if I do an enum. Like remember we were talking about an enum. So it's gonna be enum class, my enum, right? It's gonna be something like first, second, third, or something. And now I'm gonna have this map instead of strings. I'm gonna use an enum. So my enum first, my enum second. Right, so here you go. So this is the default way of serializing in Lawman JSON, and it's going to turn this into an int, right? So I think what I need to do, this is why I used magic enum, but so I need to kind of connect this, right? Let's read the enum documentation of Lawman JSON. So as an enum conversion. Okay, so and Lawman JSON serialize. So map track state values into strings. But can I also pass a function? I wonder, am I the only one who does this? Like, can I actually make a function that says how to make a two-string version of this? Which is enum macro set of choose JSON from JSON functions. Okay, so I just needed two JSON from JSON. Okay, so this is what it is. So I do something like, on serializer, you can stack overflow if you don't pay attention. Okay, blah, blah, blah. How do I write my own serializer? Special from JSON overload. So okay. So I need to so ADL serializer does something. Okay. Let's see if I understand how this works, because I don't so far. I just copy pasted the thing. I think I need to write it in the enrollment space, and then do something like an ADL serializer for my enum. Something like that. There's a question if somebody could use make a sound for a DAW. Yes, this is the use case. Somebody could make a DAW and just write a front end for the device manager and use make a sound. Like this is exactly the goal. Like it should be used for a heavyweight, at the end of the day, it should be used for a heavyweight audio app, as well as, your simple audio app that just wants to show some DSP code. Like it definitely should work for this once I'm finished. Okay, so to JSON from JSON. Yeah, so I should be able to do something like const my enum, right? And so this is just something like j equals my enum. And then the other one should be stateful one. It's interesting because my library has something similar to this thing, but much nicer, in my opinion, with way less boilerplate than this. But I think I can just do this, right? And then let's bring magic enum, which should be include. It's not magic enum. What's it? Oh, I need to link against it. So this should be magic. No, do I not have it? Magic enum. Okay, and now in my code I should have magic enum. And this should be magic enum to string, something like that. Let's see the exact code. Integer to enum, no string, enum value to string. Magic enum name. Enum name of my enum. Sorry, of my enum. And this is fine because I think this returns this. I think this returns a std string, which JSON already knows how to serialize, and this will convert it back. So this will say my enum equals magic enum. What's the from string? String to enum. Enum cast. Enum cast of my enum. Or no, my enum. It's j get to string, something like that. Right? Am I wrong? Yeah, I think this should be fine, right? So it should cast this. And probably some error handling should work. So it should be something like if autoval equals this. Oh, it's an optional. Okay, so that's why it doesn't work. So if it works, then this should be equals to val value. I think I should also be able to do this, right? I forgot the std optional stuff. I think this should work. And then yeah. So I think this should work. Let's see if this works. Let's see if I got the this implementation correct. Yes, here you go. Hey first, my key second, right? So that now it takes the actual names of the enum. So if I do something like third, whatever. Next, let's do another one first, right? So it automatically was able to serialize. Oh, this is nice. First, third. Wait, hey is first, right? These are on in different order than what I put it in, but it's fine. Next is third. First is first. My key is second. Great. So this worked. So this is a way to do this, and I can probably add another template around this, right? I can actually do I wonder if I can do something where if it's an enum, just default to this, so I don't have to write this for different enums. So I can probably do, let's see. Yeah, like, will I have to use something like a std enable if for this? Like, because I wanted to make this template, this thing to work with any kind of enum, right? I don't want to rewrite this for each of my enum types. I just want this to work. So let's think of what's a good way to do this. I can maybe, I guess a simple way to do this. Yeah. So Alanda can actually, you can actually help me with this. So I want so that every type of enum, if it answers the, there's a trait that says, is this an enum, right? Like there's, if I go to here, there's like a C++ trait. Is enum. I think that's the thing. Std is enum. So I need that if this works, std is enum v of the type. So it's probably something like a std enable if, I think, right? I absolutely hate std enable if, but I guess this is the situation where you have to use it. I think so. I think I need to do something like that. Like something like let's ask Gemini about this, right? So I want to ask Gemini about give me in modern C++, I want to specialize this might be not be in the screen. Yeah. So in modern C++, I want to specialize a function, specialize a function to only work, to only get resolved with enum types. The implementation I need is to specialize an Loman JSON serializer that looks like this and but I want this to compile for the same thing, but for every type. That's a that's an enum in the same way. How would that work? Okay. Here you go. So let's see if what it does will compile. Let's see if this would work instead of my implementation. Look at this. Look at this beautiful Gemini generated code. And because I've done this, that means I can also now have another enum. Right? Oh, no, this still says my enum. That's not good. This is just enum type. Yeah, let's see if this still compiles. Good. Very good. Okay, so now I should be able to write a bunch of enum classes, like enum class, my enum class, other enum, and this, or, whatever. Maybe I would have to like yellow, green, blue, right? And this should allow me to do other enum, green, let's put some values in here, green, blue, yellow, green. Yes, here we go. So this works. So now I have something that I can just generically pass any enum here, right? And this would use magic enum. So that's a very nice way to do this, so that I'll be able to just serialize like here, like a complicated object. This would what's going to happen to user code. So I'm just going to actually create like a kind of almost like a separate serializing library. I think that's going to be like a separate module from the drivers library, because you might not want the serializing features, I guess. And those depend on external library code or something. So I'll do, so there's make a sound, and let's call it serializing or something. Oops, not here. I wanted to call this, sorry, inside make a sound. I'll call it serializing. Actually, it's header only, so I don't need to make it another model. I just need to make it another header. So let's call it, serializing.h. And I'm just going to move everything from my example code. So that means that I need the includes from here to be here. I need the templated version of this to be here. And now I might need to write just a few other things for my actual types, but we'll see. It's possible that Enloman can pick up some of my types. So we're going to see how that works. here I can just include something like make a sound serializing this, right? And I have my enums, my maps, blah, blah, blah. And this works good. So I can now, let's commit this thing because this would be a good starting point, I believe. So okay, so added initial. Let's not commit the example app just yet, but just everything else. So let's add initial serializing code that depends on Lohman and Lohman JSON and magic enum. Okay, so I got this, and now let's start to work on serializing my actual types. So what this needs to do is this needs to bring in the make a sound header. Oh no, it needs to bring the device info header. And basically what I need is a way to get this as a string. Like this, the actual method would be something like, or get this as a JSON. So let's start with a JSON. So this would be something like JSON or JSON, and it should take a make a sound. Let's put this in the make a sound thing. Namespace make a sound. Let's even do make a sound. Yeah, let's do make a sound. Let's make a sound, and this should bring in. First of all, I'll do something like using. Sorry. Namespace JSON equals normal JSON. Const. Did I screw up on the namespace? Make a sound. Oh, because it's not namespace, it's using. Okay. This is not called device info. Am I out of it? Make a sound. I'm including device info, which is correct. What am I missing in my code? Wait, what? Oh, I didn't close the namespace. The previous namespace. This is fine. Okay. Okay, this is good. Good. So here's what I'm doing. What I'm doing is, let me switch to the next song that I'm listening to, because it's some song that has vocals in it, and whenever I hear vocals, I cannot think of code. Okay, so I would need, I think in theory, I don't think it can do this by itself, but I should be able to return info, but I don't think that's going to work. I think I would need serializers for these. Right? But let's see what this says. Let's go. So if I will have a format here, or info.format. Oh, sorry, it's called native formats, right? So if I'll do this, info.native formats, can you do that? Yes. So it can do the list of formats, which is the list of list of possible formats the thing supports. I think this should compile. But what it cannot do is it cannot do the full structs. Right? So for this, I think I need to tell it what to do, right? So let's look at the documentation for Llama JSON again. This is something like Llama JSON. There should be something here that says how it works to get my custom structs into a JSON without writing to JSON from JSON manually. Okay, here we go. Define type non-intrusive. Oh, name member. Okay, so I think like this means that I should be able to do, like I said, I want to return this. I need to be able to do something like namespace NS. Is that what I need? Okay. But how do I put in the type? Should I find person can be created with? Okay, so this is what I want to create it as a member of the type. But if I don't want to do that, can I do this macro for external types? Yeah, I might need to put it as a member, which I don't really want to do. I don't want to make this but maybe this is a type, like maybe person is. Oh, okay. So this might work if I'm in the same namespace. So I think if I do device info and then do ID, yeah, that's how it works. So I think I just have to do this. So I just have to write down the name of the members. So output channels, input channels, what else? Duplex channels. Is default output, is default input, is default input, is default output, sample rates, current sample rate, preferred sample rate, native formats. Yeah, so these are the kind of things that would be nice with reflection, but again, I like the manual typing. So I just want to say, Lana says that this is one of the things that would be nice with the C++ reflection. Yes, it's greatly missing. Like it would definitely save me a lot of time in something like a demo. But there's something nice about also being able to manually do this, because just to give you an example, there are structures that I might not want to serialize. That's actually one of the most common things that happen a lot. That there's some private members here that should not appear. So doing all the members by default is not always the best idea. So there's also would need to be like some manual thing, or I might want to change the strings. But for now, I'm not going to change anything because I'm trying to keep it simple. But it's actually very possible that when I want to do like a future-proofed version of this, then I would manually write all the strings to make sure that this, that somebody changes this and all the presets don't load. Like that would suck. Like if this would break. Yeah. So let's talk about the reflection thing. I think there was a way to distinguish between privates and publics. The getter was whole different. Yeah, but I think this is it's not as a public and private problem. The problem is if you think of a class like more complicated classes and struct and stuff, some things here should just be internals. They should just not be serialized. Even if they're public for the code to use, they might not be not need to be restored in this way. For example, it's sometimes, in audio related classes, you might have some float that gets stored, but then you have some atomic that's used for real-time synchronization. So reflection is greatly needed. Like it would make my life so much easier when doing this kind of debugging, but it would also, there would also need to be a lot of manual control in this. Yeah, and indeed, language like Java do it very nicely, and Java with annotations. Yeah, a lot of languages have built-in support for properties that kind of get converted into this. But anyway, I wanna get things going. So I'm going to. So I need this. I think if I have this thing be above this. Okay, here we go. So now, before I had this macro, this didn't compile, but now it did because it knows how to convert this type into this type device info into JSON. So let's go over the types and see if I can go through all of them. So I have device info. I have errors in enum. I don't need to convert it because I wrote my template already. Stream parameters. I might need to do that. So let's see, stream parameters. Same problem. Let's add this for stream parameters with device ID and channel type. I think it's called NM channel device ID. Device ID. What did I do? Device ID. Stream parameters. Device ID. And channels. And what did I use there? First channel. Yes. Okay. All this macro magic. Okay. So now you see, now this will compile. This knows how to do that. Same as, let's see what the next type is. Flags is an enum. I already have it. Stream options. So you do the same with stream options. The members that it has are flags, number of buffers. Oh, crappy name. I have to change these names. So what did we say? Flags, number of buffers, and stream name. Name and priority. Priority, stream name, number of buffers, flags. What's wrong? Did I forget some semicolon? Did I? Flags, number of buffers. Oh, maybe it doesn't know how to do flags. Okay, flags, another one. Let's do flags first. Flags. Non-interleaved, minimize latency. Hog device. What else? Schedule real time. Else use default. These are a bunch of flags that you have to pass. And jack don't connect. Okay, now it knows how to do that. knows how to do stream options. Great. What else is above this? It's an enum. This is going to work. Stream config. Stream config. So it's input, output, format, input, output, format, sample rate, max. By the way, I could just do this thing in the class, but I don't want to do that because I want this to kind of not be included as part of the library. So if you want to do your own serialization, that's fine. Like you don't have to include my JSON library or this JSON library. So what's the problem here? What can they do here? Stream config. Is the problem that it's stood optional? I think it should support optional, right? Maybe not. Is the problem, like, let's say I remove these. Is these okay? Yes. Right? This will compile? No. What doesn't it like here? Let's see. Let's start with format. It likes format. Okay. Let's see what doesn't it like. Oops. Okay, it doesn't like the options because it's stood optional. Why doesn't it like stood optional? That's interesting. Maybe there's no support for stood optional here. But I can add that, so I can do the same thing, just like I did here, just with stood optional. So let's see, how do I do that? This is some template magic. Let's go back to beautiful Gemini. Here you go. It pretty much did this perfectly. Yes, and now it liked options as well because it knows how to do a stood optional. I'm not sure why this isn't built in, by the way, but whatever. Here you go. Right, should so now I've added I've explained to it how to work with the stood optional, and now these complicated types that have optionals are good. Audio callback info should not actually be serialized, at least not for now. So I think I'm finished on this part, and I should be able, in theory, stream config, right? Yes. So I think now, if you include this, you should be able to convert types into JSON. So this is like a nice helper. Now let's see how this is going to be used in my user app, right? Let's remove all this stuff. I don't need this config. I can remove all this stuff. So I should be able to just spawn a manager, tell the manager to get devices, and I should just be able to, this is a vector of device info. And Loman already knows how to serialize device info, so I should be able to just tell it something like O2 JSON equals and Loman JSON initialize with this, right? Now, maybe I should do, if I will do something like a Loman. No, why can't I do a vector? Oh, right, because I didn't include this. Let's include, but I did. Wait, I haven't included. It should know how to do all these types, right? If I will do a device info, make a sound, device info. No? Oh, I thought it was going to resolve. Why isn't it? Is resolve. Okay, just took a second. Just my CLion took a second to see what's going on. It does work. Okay, so I should be able to do O2J equals enlawman JSON. Yes, it was just CLion who was slow. So my implementation worked perfectly, and I should just be able to std cout J dump. Now let's see what all my devices look like. Awesome. Let's look at this. This is going to be beautiful. Let's just because this is, I have a lot of devices on my system. I probably should connect some of those, disconnect some of those, especially because I have a bunch of virtual devices. But let's just open VS Code just to have nice JSON visualizer. Go away from me. Perfect. Okay, so this is the visualizing of this big array. Let's close this. So this is the array of all the different objects that are in my specific system, right? So my specific system has has one device with the name of Apple Inc. Studio Display Microphone. It supports these sample rates. These are the native format, right? This is really why we did all these like custom types for with the enums, and I removed the bit sets. Like this is really it. This should be user exposed. This is so nice, right? This is a way to do a very, very nice reflection on the state of the system. You can just move this into a preset of your program, so you can just save the last configuration, for example. You can, load this. You can reflect on it. Like this is very nice. You can work on this preset from JavaScript if you're scripting the thing and just want to move it. Like you don't have to use a C++ program to touch the types. And this should convert back and forth, right? You can see all these like interesting devices and everything that they support, and this is super nice. Now, let's reflect on a specific config, right? Because when I created a config, before, what I did was I wanted the I wanted to do something like auto config equals manager get default config, right? So this just shows the default devices for my system. Default audio devices are connected to my system. So what this did was, this gave me a file, something called stream config, which I think I did already serialize, I guess. The one thing that's interesting here, I might want to save a few more things in here just because I suspect this will be slightly too low level just because of the way I store the data, but this is coming soon. So what I will do is when I save the config, where's my example app? Okay, but I should still be able to do O2 JSON equals enlawman JSON. Funny, because I've imported, I can actually do make a sound JSON as if it's my type. Make a sound JSON config and std cout. By the way, this is something that this is such a pattern that I'm going to do while debugging. So I'm going to add this to my serializing code. I'm going to add a template helper that will just help me get the JSON and print the JSON, just because it's so common that we would need to do this while debugging. So I'll just going to do type name T. Let's do something like JSON. Let's do get JSON or JSON const T object. Just return object. And then let's do another template like this that print or something, print the object. And what it's going to do is, or let's first do std string get JSON string. This will also come in very handy probably. Takes this, return get JSON object dump 4 template type name T, and I'll just do int what do they call it, indentation indent equals 4, just because you might want to customize this. Okay, get JSON string, and it would just do std cout of get JSON string of and of object std and L. Good. This will come in so handy when debugging these types, because now I can just do, you know, make a sound, print manager get default config. Like, I don't need to do all this boilerplate of types. This would be much easier when working with these nice types. So I simplified it. I got a print. Okay, I'm back. Are everyone still here? Sorry for the technical problems. Hopefully my audio works. What happened is, and I'm not sure why that happened, but who knows? I was clicking debug on this code I did, which just us serializing, and it immediately stopped audio. And maybe I just disconnected something physically here. I don't know what I did. Anyway, I'm back online, and basically what I just did, to bring my IDE window back. Here it is. Okay. So as you can see, what I did was I can remove this code for a second now. I had all I did that the example program was doing was that it I wanted to be able to do, I had all these like template functions that I added so that I could do just print any of these files. In this case, I wanted to print the config file. And I'm going to try it right now and see if it's going to not disconnect my stream again. Let's hope. Let's pray. Running this and good. Okay, so this printed my current configuration, right? Let's have a look at it in Visual Studio Code. And you can see this is really nice because I have this really nice now interface for serializing, and this also should be, I didn't test this correctly, but this should also be able to load this from a JSON or a JSON string. Okay, that's pretty good. So the only problem with this is, even though this is kind of correct, like in the sense that you see this loads the ID, and I think the ID, if I remember correctly, it's possible that the ID should generally be consistent, like in the sense that if you disconnect a device, I think, and if you reconnect, I think the device ID should generally be the same. Like the system should detect as the same ID. I'm not sure about that. Like somebody who knows more maybe can tell me. What I do not like about this is that when I have a specific config, because this config is really a preset for a specific connection of the user, right? If you think of a program like a DAW, right? Let me load some DAW here, right? For example, like let's load Reaper. Okay, so if I'm in Reaper and you have a setting for this, so basically, you have all these devices. These are exactly the same devices that I saw in the list, right? My studio device, speakers, microphone. These, when you think of how Reaper works, let's say Reaper used my library. Reaper would query the list, but then it would store a specific setup, right? The specific setup is this device, studio display speakers, sample rate is this, block size. Like it's basically going to decide on one configuration so that it can play it back for me in the next time that I load the project, right? This is a user of this library, right? A theoretical user. And the problem I didn't like with this is, even though this should be enough information for the system to load this, you can see this loads that it's that device ID and this whatever. Maybe I need to add like a little bit more of like of the verbal information about the device, like tell me that it was the RME device or the internal laptop speakers or something. So what I might want to do is add this information to the config itself. Like I can do something like so the actual config, right? Because I call get default config, and what this does is it, this gets the actual, so you see I created this thing. When I gave you the device info, I only picked up some of the information. I don't know if I like it. I don't like this. I I would prefer if this would have the full device info in it instead of, or maybe in addition, I guess, right? Because I can also do, yeah, let's just store the info inside of this thing. So yeah, I think this should work fine. So I should just store the full info. And let's see, somewhere in the usages, I'm just grabbing the ID. So I'll grab it from the, let's call it device. And I don't want this member to exist. Device to use. Something we did also about the number of channels, which is not correct. Like what I did was, when you initialize this with a device, I did that. I'm kind of trying, I just did it for the demo really, that kind of defaults to either 1 or 2 channels because that's the default. But I probably should do something like, and num channels or something, right? How to do that? Stream parameters, right? Yeah, I should probably do something like int num channels something equals -1, and if num channels is bigger or equals to 0, then use channels equals num channels, no, right? Else remove this because I do want the user to be able to specify something like surround or multi-input configuration or something like that. So I just want to first of all say hi to everyone who's joined in, recently. I'll give for people who haven't been here since the start, I'm making a device like a driver wrapper library in C++, like an audio driver which would wrap. Currently wraps a library called RT Audio, and the idea is to get a nice interface to use, for audio apps in a cross-platform way. If there's any questions, I'm streaming this on a bunch of different platforms, so you might be watching this on YouTube, LinkedIn, Facebook, Twitter, X, or I think that's it. So let me know if you have any questions, and I will try to answer and explain what it is I'm doing. Last thing I did, which was, I'm just wrapping this up, is I did some serializing code so that all the types of the devices, including all the information of which audio device they had and all that, it will all just be saved and loaded to a JSON, which is very important when you want to do some UI interaction, like we just saw with Reaper. The UI needs to show a bunch of details about the device information. So yeah, let me know in the comments if you have any questions, and I'm just gonna finish this thing and wrap this up pretty soon. So let's see. I've get JSON, get JSON string, print. And just for fun, I probably also need from JSON too. So I did type T, and this is going to be a T from JSON. This should be from JSON. One should be from JSON string that takes std string. And the other should be from JSON. JSON. And I think this should just work, right? Like I should be able to do, see if this works, but I should be able to do this like this. Like, let's say this is like make a sound, get JSON, manager, get default config. I should be able to get the config by doing auto config equals from JSON, make a sound to JSON. No, not this. Get JSON. Oh, no, I need from JSON. Sorry, from JSON of type make a sound config, stream config. It will take a J. Let's see if this is going to work. No, oh, here we go. These are my calls. Info. Yes, so this works, right? Here is my config. Input, device. Oh, here you go. And now, this is kind of cool. So now the input and outputs are actually storing the names, right? So that means that if I would actually print this, which is what I just changed. So if I would just do make a sound, print, right? I don't need this. I would just print this. I'll just print the config. This should tell me not just the ID and stuff that the system needs to load this. It's going to help me also with what the user stored. So for example, let's say I want to show the user what they loaded before they loaded. Like, hey, are you sure you want to hook into this device? Like, I want to show it to the UI. I know now everything about it. I know that this is the name of the device. I know how many inputs and outputs it has. I know the sample rate that it's supported, the number of sample rates that it's supported, etc., etc. So this is nice. Like, this is actually super useful for what I'm trying to do. Serializing and deserializing from a JSON object. Good. So I got this. And what else do I need to do? There's something that I forgot. No, I think this is pretty good. This would be a pretty good commit. So let's commit this and say added conversions between all the types to and from JSON. Awesome. Okay. Whew. That's a lot of work. How's everybody doing? Let me know what's up in the comment section. If you have any question about this, there's a lot of details involved. It's quite a process for sure. I would just say, if you're around here, you should definitely check out our plugin company, Modalix. We make really cool plugins that do sequencing and sampling and some crazy effects. You should really check those out. Okay. So with this, I might finish the stream. I've been streaming for 3.5 hours. It's quite a lot. I might be back later today, or maybe I'll just do it the rest some other day. But this is it's definitely a nice segue into finishing this. So thank you everyone for sticking around, and I will be back soon.